In this video, we are going to be looking at question number 5 from our Test 2 prep packet. This one really just has to do with our big joint distribution table. This is where I'm going to ask a lot of the kind of law of probability stuff, for the probability law kind of calculations, right? The formulas that we had in there for the different probabilities, right? For the probability of a union, probability of an intersection, so on and so forth. Right, you can identify it by the giant distribution. That's usually a pretty good giveaway. All right, so we've got this table. All right, we've got 500 people, and we asked them what their favorite ice cream flavor and TV show was. All right, so here we've got our TV shows, and here we've got our ice cream. Hope nobody got those confused. But if you did, tell me where you're getting ice cream, because sounds interesting. All right, and then we're going to use this table to answer the following questions. Right, one of the first things that we're probably going to want to do when we get one of these is we are going to want to add up these lines, these rows and columns. Right, this is going to be very helpful. All right, so if we're looking over here at Brooklyn Nine-Nine, we add all of these up. All right, we get 175. That tells us that there are 175 kind of observations of people saying Brooklyn Nine-Nine in this. All right, if we're looking at supernatural, we're going to do the exact same thing. All right, we want to add all of those up. And then, of course, we want to do the same thing for Peaky Blinders as well. I didn't do, and I didn't actually add that one up. So let's see. So that's 166. It's 195. All right. All right. So then we've got those all ready to go. All right, and then we're going to want to do the same thing with the other ones. Again, this is just going to kind of go, just add them up. Relatively straightforward. All right. So for Buttercon, we've got 144 mint chocolate chip. We've got 162. And then for Turtle Tracks, I don't know if I've got that anywhere. Do this again. So 198. Okay, so if we, one thing with this one, all right, this example, up here I say that we asked 500 people, right? So that's our kind of capital N, or our kind of sample space, right? The size of the sample space, all right? The number of possible outcomes, however you want to look at it. But if we weren't given that, a good way to find that number once we've done this, especially if we have done this, is just add up all the numbers that you have on one side of the distribution. Right? You don't want to add up both of them because you're going to double count them. So there. So we'll probably kind of flip back to this whole thing. I'm going to go ahead and erase these. Just kind of assume that y'all got these down. I'm going to be referring to those numbers as we go along. All right. So this first one, this first part says, what is the probability that an individual's favorite show is Supernatural? Actually, I'm probably going to just do these first couple. Well, no, that's ridiculous. We're not going to do that. All right, so what is the probability that an individual's favorite show is Supernatural? All right, so we're going to switch to the blank screen. All right, so if we're looking, all right, so we're saying, all right, what's the probability that someone's favorite show is Supernatural? Or really, what is the probability that a randomly selected individual from this pool would say that their favorite show is Supernatural? All right, so to do that, we're going to use the classical approach to probability. All right? So that's the number of observations or kind of number of outcomes in the event. In this case, our event is saying that your favorite show is Supernatural, right? Divided by the total number of possible outcomes, right? So here we would look for that sum, the sum of our Supernatural row. That's going to be 130, and then we're going to divide by the total number of outcomes, so 500, 0.260. Right, our next one, I'm not even going to flip back for these next two just because they're very similar. All right, the next one, 5b, says, what's the probability that a randomly selected person would say that their favorite show is Brooklyn Nine-Nine? That's not how you spell it. There we go. All right, so Brooklyn Nine-Nine, same concept. All right, we want to come to our distribution. All right, Brooklyn Nine-Nine, we're going to add up all of these numbers. We're going to get 175. We're going to divide it by 500, and we're going to get 0.350 as our probability. And then for C, again, pretty much exactly the same. What is the probability that a randomly selected person would say that their favorite ice cream is butter pecan or something to that effect? We got a little, and then the yellow doesn't really show up that well. So, but you can get the idea. We're going to add up all the numbers in the column, starting with butter pecan, that first column right there, which is going to be 140. We're going to divide that by 500, and we are going to get a probability of 0.280. So those are our first three. Those are the relatively simple ones, the ones that are just, I mean, all of these are just dividing numbers, dividing stuff, putting stuff on top of stuff, however you want to say it. But those ones are slightly easier. All right, there we go. All right, so this next one, looking at D. It says, are Brooklyn Nine-Nine being an individual's favorite show and butter pecan being an individual's favorite ice cream flavor independent of one another? All right, so to answer this, all right, so just as a refresher, all right, for kind of our events A and B to be independent, the probability of A must equal the probability of A given B, and the probability of B must equal the probability of B given A. Alright, so that has to be true. Alright, so one decided to try to make it a little bit easier on you guys. Alright, so I had you already calculate some of the stuff you need, granted the easiest stuff to find, right? So we've already found that the probability of somebody saying Brooklyn Nine-Nine, I'm just Brooklyn, I don't know if I'm going to fit that all in. We're just going to say B99. I think you guys will know what I'm talking about. Alright, so Brooklyn Nine-Nine, no, that's going to bother me. Also, that's not the color I wanted it in. Alright, so the probability of Brooklyn Nine-Nine is 0.350, and then the probability of butter pecan, alright, which we're going to abbreviate as BP, had a probability of 2.08. So we got the starting ones. So we need to just find those conditional probabilities. Alright, whichever one we want to do first, doesn't really matter. We got to start somewhere. So let's look for the probability of Brooklyn Nine-Nine given butter pecan. Alright, so I really like the joint distributions for kind of this reason. Alright, so when we are looking at this, right, when we are looking at these conditional probabilities, right, we're saying, right, that what kind of this thing to the kind of left, or excuse me, the right, no. Yes, the left, no. I'm going to get it eventually. The term to the left, no, the right. You know what? This is just not going well for me. That's all right. We will persevere. This one, right? Whatever's, no, I got to say it. Whatever's to the right of the kind of line here, that's what's given. All right, so what we're saying is we already know that. All right, so we already know that kind of this observation has said butter pecan, so we don't care about any of the rest of this. All right, so this is our total sample space, right? This kind of box we've got here. So our kind of, this is where our denominator is going to come from, right? We're just going to add all of these up, right? And we're going to get, right, 140. We probably already have that if we kind of wrote this stuff along the outside, right? Then for our numerator, right? Well, 1. That's still true, right? We still only care about this, right? So if we're only looking in this box, right, we're asking about Brooklyn 99, right? Well, right there, right, Brooklyn 99, there are 49 kind of occurrences of Brooklyn 99, right, when we know that we're dealing with somebody whose favorite ice cream is butter pecan. All right, so we get 49 over 140. Right, and then once we plug that into our calculators, we're going to find that 49 over 140 is 0.350. All right, so that's great. We've kind of proven the first condition, right, but we can't stop there because both have to be true, right? So not only does Brooklyn 99, the probability of Brooklyn 99 have to equal the probability of Brooklyn 99 given butter pecan, right, but the probability of butter pecan has to equal the probability of butter pecan given Brooklyn 99. Alright, so once again, just going to jump back over here. I'm going to change the color of this. Alright, so this time, alright, what's given, we might not be able to see that because it's the yellow, alright, but we'll just, as a reminder. Alright, so what we're given is Brooklyn 99. So we only care about this row of data, right? And this is our this is our entire sample space. So adding all of those up, we're going to get 175, right? And we have that from some of the other problems we did as well. Right, then once again, and I'll change colors to circle this. All right, we're going to look, we'll see, well, in this row of Brooklyn 99, how many times do we get butter pecan, right? Same spot, it's the intersection, right? So we're going to get that 49. All right, so that's where we're getting those. All right, now we can actually see this. All right, so once we actually calculate that, 49 divided by 175, we get 0.280. Right, so in this case, you know, are they independent? Yes. All right. Why? Probability that of Brooklyn 99 was equal to the probability of Brooklyn 99 given butter pecan, and probability of butter pecan was equal to the probability of butter pecan given Brooklyn 99. Right? So that would be a complete answer for D. So kind of a longer one, but actually definitely the longest of this entire set. Right, but that is how we would look for one. That's just a good kind of good practice in these conditional probabilities. Although I think we got another one coming up, as well as kind of the concept, the idea of independence. All right, so the next one, so that was part D. The next one is part E. So what is the probability that an individual's favorite show is Peaky Blinders? It's supposed to be an S down there, but that's okay. All right, given that their favorite ice cream flavor is mint chocolate chip. All right, so if you looked at the video kind of telling you how to figure out what you're being asked for, right here, this is one of the spots. These next three, we're going to be kind of talking about those a little bit. So given, right, whenever we see given, that's telling us we need to do a conditional probability. All right, so what we're doing, all right, Peaky Blinders given mint chocolate chip. All right, so the way we would write that, of course, is the probability. Right. Wait, I can't start writing that stuff. It's way too long. All right, so we're going to do PB. All right, so PB and then line and then whatever we said was given. All right, mint chocolate chip. All right, so the probability of Peaky Blinders given, right, that they said their favorite ice cream was, or flavor was mint chocolate chip. All right, so once again, we're doing the exact same thing that we did in that last question. All right, what we are given, all right, is that the person's favorite ice cream flavor is mint chocolate chip. All right, so we only care about this column. All right, we look for where that intersection with Peaky Blinders is. All right, we see it's at 29. All right, so when we go in to fill this in, right, the sum, right, one, we've already got 29, right, that's our numerator. All right, and then our denominator, when we add up kind of mint chocolate chip, is 162. All right, so the conditional probability, once we simplify that, is 0.179. All right, so again, this is that kind of the intersection of, or probability of the intersection, or if you're doing it like this, it's just the intersection, right? How many events, right? How many outcomes are in that, and then divided by, all right, whatever is given, right? That's how we're going to solve those. All right, then for our next one, 5F, it says, what is the probability that an individual's favorite show is Peaky Blinders and that their favorite ice cream is Turtle Tracks? All right, so this and, when we see an and, that's going to tell us we are dealing with an intersection. All right, so we should be looking for an intersection when we see that and. All right, so intersection of Peaky Blinders and Turtle Tracks. All right, so once again, all right, Peaky Blinders, we'll do PB, all right, and then to signify that you are looking at a intersection, right, you're going to use this little upside down, or it's not upside down, right, this regular side down in looking thing, right, and then whatever the other thing is. All right, so Peaky Blinders, the intersection of Peaky Blinders and Turtle Tracks. All right, so these are fairly simple. There is one thing that I want to note here in a second, but right, to find, all right, you know, this actually, no, there's no way to change that, I don't think. All right, so with our intersections, we are looking at just that classical approach to probability, right? The number in the event divided by the total. In this case, all right, we've got Peaky Blinders, all right, so we know, all right, we want stuff that's in the Peaky Blinders, all right, and in Turtle Tracks, right? So the only crossover right there is that 113. All right, so we know that our numerator is 113, right? And then our denominator in this case, right, it's that entire 500. Let's make that a different color so it stands out. It's that 500 right there, right? Because the intersection we're looking at, right, the whole thing, right? Not just a piece of it, right? So we have 113 over 500. All right, so once we get that, we're going to get 0.2 0.226. All right, the reason I kind of harp on that is because a lot of students will confuse the conditional probabilities and the intersections, or probabilities of an intersection, right? So these things do not equal one another, right? In fact, you have to have this one to calculate that conditional probability. You have to have that intersection. Oh, excuse me. All right, almost made a glaring error right there, right, in my notation. All right, they do not equal each other either. All right, those are not equivalent. A lot of students will just get them confused, right? And then say use just divide by the total number for total tracks when they're doing their intersection, or divide by that total number if they're doing a conditional. All right, if you do that, it's going to mess you up. You're not going to get the right answer. All right, so that's something to look for. Then I think finally for this one, G says, what is the probability that an individual's favorite show is supernatural, that their favorite ice cream is mint chocolate chip, or both? All right, so when we get this or both, that's telling us we are looking at a union. All right, so when we are looking at a union, we have to look and say, actually, I kind of preemptively jump to the one. All right, is one thing we have to ask is, are they mutually exclusive? All right, so for these, it's very simple because we can look and we say, okay, we're talking about supernatural and mint chocolate chip. All right, and we can see that they have that intersection. They have those common outcomes. All right, so they are not mutually exclusive. All right, and so we are going to have to use that eighth law of probability. All right, but let's go ahead and actually look at that calculation. So when we are doing our eighth law of probability, all right, we are saying that the, all right, so man, gotta pick shorter things. All right, so what we're looking for here, right, the kind of classic, if we were looking at, all right, probability of A plus the probability of B. Whoop. All right, first we want to start off with our actual thing. So probability of the union of A and B. All right, so if our events are mutually exclusive, it would just be this, right? So this is our sixth law right here, all right, if we don't do anything else to it, all right? But if we change it to the eighth law so that it's generalizable, all right, so that we can use it for any two events, all right, remember we have to subtract that intersection off. All right, so what we need is the probability that a person's favorite show is supernatural. So we would do this just like we did those first three problems. We'd add up all the numbers in the row with supernatural. We get 130, divide by 500. Then we would add that to all the numbers in the column, mint chocolate chip, add those up, 162, divide that by 500. And then we would subtract by the intersection, right? We saw that kind of place where our supernatural and mint chocolate chip intersected, right? That's why it's called the intersection, right? There was 39 of those, 39 observations, right? And so we need to subtract those because these are being counted in the 162, and they're also that's supposed to be a different color, but that's all right. But they're also being counted in the 130, all right? We only want them counted once, so we got to take them out of one of those spots. All right, here we could add these up, or we just put it all together and get the calculator to do it for us. Either way, we should come out with a probability of 0.506. Right, and that's it for number 5 on our test prep packet. In the next one, again, kind of these sign-offs are a little redundant just because You guys, if you're doing them in order, you know, and if you're not, then you know which one you're looking at probably. All right, but in the next video, we'll be looking at problem number 6, and I'll see you in that video.